Hello,
Hi,
George.
how are you?
Thanks. I'm doing good, thanks. How are you?
Okay, I'm pretty good. I'm pretty good. You know what? I was in a room with a bunch of people.
Okay.
I was wondering, what's the probability that two of these people share the same birthday, day of the year,
Hmm.
right?
Okay.
So I was like,
Well,
go ahead. Sorry.
no, I was just gonna say, thinking about it, would the probability be 1 out of 365?
I think 365 would be how many different options we have. So if
Okay.
there were two people in there, we can say that I guess it's 1 out of 365 that the second person has the same birthday as the first person. Yeah.
Okay.
Okay. So now what if there's three of them in there? How would that change?
Gosh. Well, that would be 1 multiplied by 1/365 multiplied by another 365, would it?
Possibly,
Hmm.
possibly. But then there may be some overlap there that all three may share the same birthday, right? So if I said at least two people share the same birthday, there's the option of all three having the same birthday or two having the same birthday, right? So there's a little bit of
Hmm.
overlap there, right?
Okay.
Okay. So you would say that the probability increases, right? That there at least two people share the same birthday if there's a third person in there.
Sure.
All right, let me ask you this question. How many people would have to be in the room for me to have about a 50-50 chance that at least two people share the same birthday? What would you say? What do your instincts tell you?
I have no idea where to start.
Well, maybe some people I think kind of look at it and say, well, there's 365 days in a year.
Hmm.
So maybe I need half of those people to get a 50% chance.
Okay.
Does that kind of sound, it kind of sounds, it sounds
It sounds like a step
some,
in the right direction.
yeah, yeah. But the issue is if I like so if you had to guess, would you guess like half of the 365, whatever that happens to be?
Probably.
Probably,
Yeah.
what if I told you that if there's 23 people in that room, you have more than 50% chance of two people sharing the same birthday?
Huh.
Does
Well,
that
it'd be interesting to hear where that came from.
It doesn't sound that intuitive, does it? Because there's
No.
23 people, right? So you're like, well, wait a minute, 23 people, that would make it a fair bet that either
Mm.
you do or at least two do, or nobody does. Nobody shares the same birthday. We basically are able to figure this out, right? So if there's 30 people in the room and you say, I bet, stand up and say, you know what? I bet at least two people share the same birthday. You have better than 50% chance of winning that bet. So this is almost, if you were like really wanted to take advantage of people who didn't understand statistics, you'd be able to, make them take that bet. But
Nice.
we don't use our superpowers to against humanity, do we?
Not on this occasion.
Not on this occasion, but and we'd hope that nobody else would, but
Indeed.
maybe that would be a lesson for people to go out and learn a little bit more of statistics. Okay, so I think the way that we'll be able to do it is using this particular. I kind of mentioned a little bit that there's kind of a situation where when we say at least two, that means that two can, or three can, or four can, or everybody can share the same birthday in the room, right?
Sure.
So maybe it'd be a little bit easier to figure out what the probability is of it not happening,
Mm.
and then take that probability and do what with it?
Take the negative of that.
Not the negative.
No,
No.
it would be 1 minus that then.
Yes, that's right. That's exactly right. That's exactly right. Okay, cool. So let's kind of see how we might figure it out. Okay, so we were, let me actually put up a whiteboard.
Okay.
And then, okay, so let's see. Let me get this situated here. All right, so again, I've been practicing my handwriting since the last video, so hopefully a little bit better. Okay, so if we want to find the probability that at least two, so we'll say at least two. Is that how you spell least? Two
Looks right to me.
birthday. That's going to be equal to 1 minus the probability no two share. Man, that's terrible handwriting already.
I'm just going to say something out loud.
Please.
When I said take the negative of that earlier, I appreciate now that it sounds like, oh, take that probability and negate it. What I meant was, if it's, you know, probability of at least two, the negative of that would be, you know, 1 minus the probability of two.
The compliment.
Yes, that's what I meant.
Compliment.
I got the word wrong.
We love compliments around here.
Absolutely.
Yeah, I know. I realize what you were saying, but I just wanted to make sure that we didn't have.
Yes.
But that's exactly right. Yeah, I knew exactly that. I knew that you knew what you were talking about.
Thank you.
So this is what we're going to try to find. So let's say 1 minus, basically, if we have a certain amount of people in the room, let's say n people in the room, right?
Okay.
So 1 minus the probability that no two people share the same birthday. So I guess we have, I believe the total amount of outcomes would be 365 to the n. Would you agree?
Sounds about right.
Okay, so when we're trying to figure out the probability, okay, and again, we're kind of assuming that every day of the year has equal likelihood of somebody being born on it. So that may not be the case because of seasonal, whatever, who knows exactly what might be happening in the background, but we're going to assume that any one day is as probable as any other day of being a birthday. Okay.
Sure.
So the first person, right, has 365 days to choose from, right?
Okay.
But now how many choices does the second person have if they can't match the first person?
364.
That's right, 364. And then the next one.
363.
363. And
I think I'm sensing a pattern here.
Yeah, all the way down to, well, I'm going to need n of these, right?
Sure.
I'm going to need n of these. So I imagine I end up with what? This is 365 minus 0 minus 1. So I imagine it's going to be 365 minus n minus 1. That sound right?
Yeah. If the first person is 0, then in order to have n people, we're going to have the last one being n minus 1.
Right. So the n minus 1. So I think this may have to be in parentheses, possibly. Right?
Okay.
So that's basically what we're going to be doing. We're going to try to figure this out for the values, for the different values of n. So I believe that the top bit can be talked about as the permutations of n, of 365 taken n at a time, I believe, is what's going to give us the top bit, right? Because if I did have, as an example, if I had, let's say 10, and I needed to permutate those 5 at a time, I'd end up with 10 ways to fill the first position, 9 ways to fill the second, right? The first, second, third, fourth, and fifth spot, right? So 8 here, 7 here, 6 here, right? So it would be this bit right here that would give me all the different permutations I can have of 10 different objects taken 5 at a time. That's
Nice.
going to give us this top bit here using 365 as the value here, and then using n as the value here. Okay, so far so good?
Yep.
You buy that? Okay, so I think what we need to do here, probably to really, prove this point, the about 23 being where we get 50% chance, I need to bring up an Excel spreadsheet. So let me do that. And let's see if I can get this whole thing going. Actually, let me share this Excel sheet so everybody sees what we're doing. Share Excel. All right, I'm going to make this a little bit bigger so we can kind of see what's happening here. Okay, so far so good. Looking okay. All right, so let's say, let me use this instead. All right, so let's put in a value here. Let's say these are going to be our n values. Okay, so n basically starts from 2, right? Because it really doesn't make sense to ask the probability of one person sharing the same birthday with nobody else. Okay, so let's start with 2, then go on to 3, and then use our nice little fill sequence here. And I'm going to go all the way up to 30 because we mentioned it before. So I'm going to go up to 30 and see what happens. So we kind of said, this is kind of what I mentioned earlier, didn't I? So let me see if I can highlight that at least or something. Can I highlight it? Anyway, all right, we'll remember it. I'll put something here. I'll put a big X here. There. All right, so now let's actually figure out the probability. So we'll say probability. We'll just use P here for these purposes. So what did we have? We said, let's have it equal, right? We said 1, right? Minus up top, we said we're going to be using permutations. So let's start typing PER. And I think permutations is one of the functions that comes up here. So the number in our case would be 365 because we're permutating 365 different days. But we want to permutate them this many at a time. Okay. So let me close that parenthesis. But now we need to divide that by, what did we say?
365 to the power of n.
365 raised to the same power, right? All right, fingers crossed here. Fingers crossed. Let's see what it gives us. An error. What happened?
Oh, no.
Oh, Lord. Oh, wait a minute. What happened here? I did something wrong. 1 minus permutations. Oh, do you see that? What did I do there? I just didn't divide. I multiplied there, didn't I? Let's do this instead.
Much better.
That looks better. Okay. All right. That was not planned, but we were able to fix it. Okay. So it should get bigger as I move along here, right? It does. And by the time we get to 10, you got about 11% chance. So with 10 people in the room, you have a little bit more than 11% chance, almost 12% chance of winning that bet.
Nice.
Looking good, eh? All right, let's go down to, I can tell that's genuine enthusiasm. You ready? Here it comes. Above 50%, man.
There we go.
How about that? So now,
nice.
Next time you walk into a room, you're going to be like, more than 23 people. There's a chance I can make some money today. But again, gambling, if statistics teaches you anything, it teaches you not to gamble. But this is almost not even a gamble. If there's 30 people, you got 70%.
You can have it as a fun party trick instead.
You think, oh, that's fair. And that's the way to end the party with statistics.
It will be the life and soul.
When people are spending way too long at the party that you're having, you're like, how can I get these people to clear out the birthday problem? All right. And if you could say, if I'm right, then everybody has to leave, something like that. 50. Now here, if you got 50 people, right, which is well less than 186 or whatever we had said before, right? You got 97% chance of two people sharing the same birthday.
Nice.
All right. So now what do you think about the birthday problem?
That's really interesting.
It is, isn't it? It really is. It's really sort of, it's not as intuitive, right? I mean, as you're thinking to yourself, how can, how can that be? And I think there was, I think I read something somewhere specifically. I don't know if you're familiar with Johnny Carson.
Heard the name, but not really familiar.
Well, Johnny Carson was a talk show host for a long time.
Okay.
Back in the States, and it was, I think it was Johnny Carson. I'm not sure. I may be wrong on that, but they heard about this birthday problem and they figured they'd run it. So what they did is ask one person, right? Because they had a good amount of people, more than 23 probably. They asked one person, hey, what's your birthday? They gave the birthday and they were like expecting somebody else to say, I got the same birthday. They did something wrong there, didn't they?
It's assuming that that person that they picked had that birthday as someone else rather than.
Yeah, they narrowed it down
to
one particular. They didn't allow the freedom to say, well, it doesn't matter what day it is. When they picked somebody initially, they picked the day. So then it was, you need, half of 365 to be able to say that you're going to get 50% chance, right? That's not the case because those days can kind of float around. My fingers are all right. The how do you call it? The background is I need a green screen, I think. Anyway, if these videos take off, maybe we can afford green screens for our next videos.
I love it. Let's do it.
Okay. All right. So how's that for the birthday problem?
That's an interesting branch of statistics right there.
Yeah, I tell you what, hey, let's try it right now. See what our birthdays are.
Okay.
Would it be spooky if they were the same day?
I would probably be spooked.
I'd be spooked too. Well, I was born on February 18.
I was born on the 20th of September.
Okay,
can't even
all
say
right,
it properly.
All right, well, it didn't work, but there was only 2, and there was what percent chance of that happening? I forgot.
It's like 0.002 or something.
That's right.
Can't remember off the top of my head.
0.0027. So yeah, not huge chance of it happening. So all right, so we shouldn't be, it'd be amazing if it was. Anyway, I'll talk to you next time, okay?
Great, thanks a lot, Judge. I'll see you next time.
I'll see you next time, and happy birthday when the 20th of September rolls around. Okay?
Thank you, and same to you when yours comes around.
Thanks. Yours is coming up first, I think so.
It is, yes. All right.
I'll talk to you soon.
Cool. Bye.